I am Pawan Bhardwaj. So I am primarily with gRPC C++ core contributor. I am software engineer at Google. With me is Ashesh from gRPC Python. He is also a software engineer in Google. So before we start, I think it's irrelevant to ask how many people are using AI right now. So how many are not using any agent right now? Might be a better question. So I don't hope so. Okay. How many have used tools in agents? Okay. And how many of you know about MCP? What is MCP is? Okay. So people who have not known, so right now agent uses various tools. So these tool communication happen over MCP. So that is a protocol. Do you people know about A2A? Okay, little bit. Anyway, we will be going according to this. So let's start. So right now it's all about agentic AI, and AI also needed a networking, right? So there are two standards which are there, emerging protocol for the networking between AI things, right? So first is A2A. A2A is agent to agent protocol. So think of it like that, like each agent we are trying to have one kind of a job. Now these agents might need to talk to each other. So what is the protocol they are using among themselves is the A2A protocol. I think it is recently introduced by Google itself. So that is a protocol by which agent talks to another agent, securely exchange information, and have coordinated effort to solve that higher level problem. Next is which I think more people are aware of is MCP. So MCP is introduced by Anthropic, I think couple of years back, not more back if I'm right. So what is MCP does? So MCP allow these agents to work with tools. So what do we mean by that? So for example, agent need a way to do certain tasks. That's why we call it agent, like agentic AI, not a generative AI. You are not just providing a prompt and you are getting an answer. You are providing some higher level thing you want it to be done, and AI is invoking this tool to execute that. So it needs tools to execute some of the functionality securely. So that is where MCP comes in. So what is the MCP standard? So whether it is reading a files from your computer, searching internal or your external database, updating tasks of your project management tool. So MCP provide a secure standard way of communication, right? Because you might have a common AI agent, but you don't want your internal database to be exposed to other people, right? So you keep it in a separate silo. So you need some kind of a communication mechanism. So that is what MCP is. So now where does gRPC comes into picture? So let's look at what gRPC evolution is. So as we know, in the last few decades, software as a service was the prominent thing. Okay, we are at the next evolution of software as a service to an agentic AI kind of a model. So if we think back, this software as a service are kind of a deterministic, right? You have a fixed APIs. You will provide this input, we will give you this output. So that is their model. But agents are not like that. They work on they reason, they plan. They don't work on this kind of a rigid spec. They have a higher level outcome from their input, right? So the API for this new evolution from software as a service to agentic AI is not some kind of a rigid specification you can provide. It's like a natural language learning, right? When you ask an agent to do some work, you don't provide a specific steps, right? You just put, okay, make me a travel plan. Then that agent will talk to other agents. They communicate with each other. So maybe there is a hotel agent, maybe there is a booking agent of Make My Trip, and these all are communicating with each other. And they're also communicating with tools as well to actually do the work as well. So this networking, this communication don't happen on that rigid specification. It happens on a natural language. So that is where we are going through. So we can think of it like that. Like earlier we used to have a big software. We divided this software into a smaller microservices which can coordinate with each other. Now similarly there is a monolithic AI. You don't want a single AI and have all the information in that AI agent itself, right? You cannot reuse, you cannot change it. It could be crucial information internal, some could be external exposed. So you are also breaking this monolithic AI into a smaller agentic AI, like a smaller agent which can communicate with each other. So now gRPC, as we know, play a very crucial role in this microservice architecture. Like you have like proxyless service mesh communicating with each other. So we need gRPC system to also evolve for this agents AI. So what is a key aspect, like what gRPC does in microservice architecture is have like a proxyless service mesh. Like you can create a microservices mesh. gRPC help you like service discovery, load balancing, security. You get observability, extensibility. So this is kind of a gRPC service mesh we have currently. Now we are saying like how about evolving this service mesh to an agent mesh. So what do we mean by agent mesh? So we mean by agent mesh, think of these services, like services as getting replaced by agents. And these agents getting communicated over MCP or A2A. So you want a gRPC transport to support these. So that's what we mean by agent mesh. Now what advantage does this provide is, so as gRPC already have like very high infrastructure in security, load balancing, so you get all those, plus you can get extra AI safety, security, agent observability, and support from these tool protocols. Like you might have already have a tool which works with gRPC, so you get that part as well. As you can see from diagram as well, like model armor. So this is kind of a security which get plugs in automatically if you have like agent mesh for security or like sanitizing your prompt, like this information should not be go out. So you can do all these things. So in short, like we are moving from like proxyless service mesh to a gRPC agent mesh. Okay, so let's see, MCP currently, if few people know, has like two kind of a transport. One is stdio, one is HTTP streamable, right? But what if our tool was gRPC tool? Like that is the case for most of the bigger companies. They have like already written gRPC tool and there is the agent who only understand MCP, which only have HTTP support right now. So what people are trying to do is just wrap it around in HTTP and sending it out, right? So this create a very friction. And you cannot use our existing ecosystem which people have built for gRPC services like discovery, load balancing, safety, security, which gRPC natively provide, right? So what do we mean by that is like, what if we have a gRPC native transport itself? Like what will happen? So it would help us, these tool owners, to not have that complex logic written to wrap all these things and have like send it out as a gRPC stream itself. So you will get all the gRPC benefit we stated earlier, right? Like you can get, if let's say you have an interceptor written for gRPC calls, which intercept for security, safety, and can work on that. So you can have that as well with these, because these are anyway now again a gRPC call. You can have like header based matching, which you might have already put in your ecosystem for gRPC call. It might be load balancing. So these things already comes up and help us with these new protocols. So let's see like some example usage. So I think Ashesh will go through these.
Thanks, Pawan. Hi everyone, I'm Ashesh. I work in the gRPC Python team. Continuing with the presentation. So MCP, like Pawan mentioned, MCP has two transports right now. One is stdio, other is streamable HTTP. And we are adding gRPC transport in the SDKs. So this example will walk you through how we are exposing the APIs for gRPC transport inside MCP Python SDK. So a quick overview for that is that we are providing the settings to the underlying transport through MCP object similar to streamable HTTP. While working on gRPC transport for MCP Python SDK, we designed the APIs in a way that there would be very minimal changes to switch between the transport from HTTP to gRPC. Let's see the example as a code. So this slide talks about the usage of gRPC transport in MCP Python SDK. Here we are showing TLS credentials as an example. On the left side, you will see the HTTP MCP server. And on the right side, we see the same server with the gRPC transport. At the top, we see that we import the fast MCP module, which is a module present in the MCP Python SDK. And then we instantiate the class fast MCP and we store it in a variable MCP. And we decorate the function add with a decorator called mcp.tool. What it does is that this function is now registered as a tool inside the MCP servers. This is how you do tool registration in MCP. So when the client is requesting for call tool, you can just give the name called add in the call tool request, and it will execute this function internally. Switching to the gRPC transport requires changing just one line of code, specifically in the run function of MCP object, which is the with the transport field as gRPC. In the last line, you can see that there is a transport field which we are setting to streamable HTTP on the left side, and on the right side we have the gRPC string given to the transport field. And this is how simple it is to start a gRPC MCP Python gRPC MCP server in Python using Python SDK. Let's look at the client-side usage of the MCP Python gRPC transport. If you look at the slide on the left side, we have the streamable HTTP client function, which gives us the read-write stream. We use those stream to instantiate a client session, and then we have the client-facing APIs, which are list tool, list resources, and other APIs like list resource template, read resources. And on the right side, since gRPC doesn't need the streams, right, read-write streams, which I just mentioned, we can just instantiate the gRPC client session and call the same APIs which are there in the HTTP client session. So, sorry about that. So, one thing which I would like to notice is that the APIs from the client is exactly same. So, moving from HTTP transport or switching transport between in the MCP Python SDK is very frictionless. And here's like talking about how we have achieved this internally. So we have designed what we call a pluggable transport abstraction. This abstraction sits underneath the APIs, decoupling what from the how. It allows us to plug in any type of transport mechanism, whether it's HTTP or gRPC or something else in future, without breaking the contract between the user, right? So moving on to the next slide, talking about the key advantages of using gRPC transport for AI protocols. Here are the few of them. So as we all know that gRPC is a faster transport, so this eliminates the need of separate proxies by handling security and other functions natively, reducing complexity. It also avoids the operational complexity of sidecars through proxyless mesh and prevents the need to rewrite the existing tools to work with modern agent protocols like A2A and MCP. The gRPC transport is designed to easily support horizontal scale and load balance deployments, which is a challenge with existing MCP streamable HTTP transport. The gRPC proxyless agent mesh integrates AI safety and security directly, along with observability tailored for agent-driven workflows. And we can also leverage the polyglot framework of gRPC using protobuf to support different programming languages across cloud and runtimes. So passing on to Pawan to talk about what's next, and yeah, thank you. Okay.
So what about next? Like because as we know, like MCP is Anthropic project, and we are not like officially, right? So what we are doing to make this whole thing happen officially, so like more and more people will be able to use it, right? So first of all, there is a proposal. So it is similar to gRFC, I think in talked in the morning. So MCP follow this system enhancement proposal, SEP. So we have this SEP 1352, which talks about adding a gRPC transport. So if you are a user of gRPC tool and you want it to be integrated, or you find this interesting, like you would be interested in using it, so it would really help if you like drop a comment like, okay, this would be useful for our company. So that will like, that's what they are saying, like, okay, if you are trying to do something officially, how many would be the user, right? That is a use case we are trying to follow up with them. For all the Python, like the example we share, we have a repo published, like it is not yet open yet. So I think like when we share this slide externally, we will have that link added here. So it's like just now kind of an announcement. We still need to get a link there. So that is like a working case for our POC that is similar to like we have created on top of official MCP SDK. So we have that SDK plus a gRPC transport on top of it. Okay. Even if like gRPC is not like kind of official transport, we have an agreement, like we are trying to make an agreement, like we will have a pluggable transport system in MCP. We have raised a PR for that. You can take a look at that. So what would enable us is like, let's say tomorrow, different people want to add like WebSocket transport or pure HTTP transport or different kind of transport, right? Like HTTP 3 or something, right? So we are working towards that as well to make it like a pluggable so people can try to do that, and it will help us give a separate module as a gRPC transport and not changing the MCP transport, so it would be easier for community to use whatever they want. As we know, MCP C++ SDK is not available, like official one. There are like couple of roaming around which are not like fully supported, and some are not production ready in terms of performance. So we are also working on C++ SDK. We have planned to open source it by the end of the year. So this will have both gRPC plus HTTP transport, so people can choose and show. And this will showcase for other SDK users to how it can happen, right? So as we know, MCP SDK is like similar to gRPC. You can think like as gRPC is in multiple languages, you can find MCP SDK in like other languages as well. So right now we, as experimental project, we had like Python and C++ done, but we are planning to add it to Go, Java and other, either in the official SDK, or we will try to provide a separate package which can work with the official SDK, and this would get supported. So that is like our broader level of plan. How this is there, I think we have time for questions. Yes.
So this initiative, is the scope of this initiative restricted for the transport layer only, or in the future, existing gRPC service and RPCs can be exposed as tools with minimum effort?
Okay. I got your question. So basically, if you see MCP, so MCP are like divided in two parts. So one is like core part, like tools and other thing, and then there is a transport part, right? How we are making it is, let's say you have a gRPC server already running, you have a service which you are already serving. Now you need to have this service as a tool. So you created some kind of a tool from that same service, but you don't want to create a separate endpoint for that, right? That is your question, right? So how we are making our APIs are, you will be able to connect it to an existing server. So your server can handle both direct gRPC request plus the same gRPC request as a tool call. So we are providing that. We don't expect people to like start separate transport. The capability would be there, but for the official people or the organization, the second case is like more helpful for them. Like if they can expose their existing tool, then only it makes sense to have like a native transport. Yes.
So can you touch upon the aspect of how service discovery using gRPC as a transport layer could help? So when we use agents in production, right, it's not just internal tools, we will be using external third-party vendors also, right? There will be hundreds of tools.
So there is like MCP registry, which I think official Anthropic is done. That I didn't mean in this slide. What I mean in this slide is service discovery is like in agent meshes, right? Like in proxyless service mesh, you might have heard like, okay, I want to connect to this service, but what is this service, where it is based on? So we meant by that way. Like you can have that tool or agent in a mesh and you don't need to know the endpoint where it is. But the actual question, like where you can find all the tools, that is like I think MCP registry or something they are creating. And I think Google also have, if I'm not wrong, where you can find tools and different kind of tools registered.
That is one thing, and there is this complexity, right? When you have too many choices, how does it zero in onto the subset? That will also be a problem, but I think it's an LLM issue.
Yeah, like we are just putting a transport, we are not doing it on a higher level, we just want that communication. Okay, I think we are out of time, so thank you all. If you have any question, you can find me roaming here and there. Okay, thank you.